Okay, this lesson is going to be an Algebra Introduction. We're going to be talking about combining like terms. When we think like terms, you got to be thinking of numbers with the same variable or numbers without variables called constants. Those can also be combined. Say you have a 2 and a 3. You've been doing those your whole life. 2 plus 3 is 5. Those are like terms. You can combine them. Now with the variable, say you have 2x and 3x. Because they have the same variable, you can also combine those to make a 5x. However, if you have a 2y and a 3x, you cannot combine those because the variables are different. Those are called unlike terms, so your final answer would actually be 2y plus 3x. Now, looking at like terms, in this expression, I see a positive 5b and a negative 3b. Remember, you got to include the sign in front of it. So when I'm doing this, the positive 5b and the negative 3b can combine to make a positive 2b. Because if you want to write this out, technically positive 5b, you can write positive 1b, positive 2b, positive 3b, positive 4b, positive 5b. And also there are three negative b's, negative 1b, negative 2b, negative 3b. Remember our zero pairs. Whenever you have positive negatives in the same, and there's a like term, they will cancel out. So that would zero out, that would zero out, that would zero out, leaving a positive 2b, which will be in our final answer. And since the 12a is by itself and can't combine with anything else, that will also be in our final answer. So this first one would be 12a plus 2b. The second one, I see 12a, positive 3a, negative 3a. Those are all going to combine to make one term with an a. So I have 12a, positive 3a, negative 3a. Working left to right, 12a plus 3a gives me 15a, and then minus 3a brings you back to 12a. Looking at our b, it's over there by itself, so that's going to be in the final answer because it cannot combine with anything else. So again, we have 12a plus 2b. Last but not least, looking at these, again, notice that the 2b is by itself. That's going to be in the final answer because it cannot combine with an a. So our final answer is going to again contain a plus 2b. I have a 14a and a minus 2a. 14 minus 2 is 12, so 14a minus 2a gives me 12a. Notice that our answers are all the same. Even though the expressions look different, just notice multiple things can be combined to create the same answer. Moving on over here, when we talk about coding these problems, when we code these, we want to use the same shape around like terms. So if we notice around our a's, we have the boxes. And notice how the sign is included in front of the term. That's going to let us know whether we're dealing with positive or negative numbers, or plus, or basically addition or subtraction problems. The sign after it is not included. Make sure you include the sign in front of it to get the right answer. So looking at my a's, we have 4a plus 2a. Positive 4, positive 2, you add them up, you get 6a. Looking at my c's, we have 5c, negative 3c, aka 5 minus 3, that gives me 2, so 6a plus 2c. That is an acceptable answer choice. Now, it can be rearranged and also be accepted as a correct answer. If you want to write the 2c first, it would be 2c, and because this 6a is considered positive, because there's no sign in front of it, it would be 2c plus 6a. Now, we just talked about rearranging these, and this was the problem, or this is the exact same answer from the last slide. Again, if you rearrange this, the positive 2c would go up front, and the 6a is right there. Both correct answers. However, if you have a negative sign in the problem, remember you have to include the sign in front. So notice there is a minus sign in front of the 2c. That also represents a negative 2c. If you want to write the 2c term first, you have to drag the minus sign with it, and the 6a comes afterwards. Now remember in our problem, the 6a was positive, which also means plus. So it would be negative 2c plus 6a is the same thing as 6a minus 2c. Make sure you include the sign in front. Notice the negative sign's in front of this one as well. The minus sign's included there. Thing to remember, whenever you see a variable by itself, remember that it has a coefficient of 1. A way to remember this is if you look at this, we just see 1x. So the coefficient would be a 1x, okay? Whenever there's a number in front of it, that tells you how many there are. But if you just see one singular one, make sure you put that imaginary one because it's implied that there is just one of those variables. Now, from what we just learned, x plus x basically means 1x plus 1x, and that will give us 2x. Now, the majority of the time when you see multiple variables in your problem, that's going to represent how many final terms are in your final answer. So we see an n, a y, and an n. So n and y, two separate variables. Usually going to mean there's two terms in your final answer. This, however, is not the case. I would start with the variable that's not going to combine with anything else. This minus or negative y, however you want to say it. That's not going to combine with anything else. So I know my final answer is going to be something minus y. Now, looking at my n's, we have a positive 2n and a negative 2n. What we learned about zero pairs, if I have two positives and two negatives, they're going to cancel out to leave me nothing. So there's going to be no n's left over. If you want to write it out like this, negative 1n, negative 2n, and beneath it, positive n, and then positive n, those cancel out, leaving us with zero n's. So you don't need to write zero n, okay? There's nothing there, you don't have to write anything. So the final answer here would be negative y. Like terms and unlike terms. This left side, if you want to write these down in your notes, this would be a good slide to pause and write this down. Like terms include the same variable. So 7y plus 9y can be combined to create 16y. 10x minus x. Same thing as 10x minus 1x because they have the same variable. You can combine that to make 9x. And last but not least, whenever we start dealing with variables, sixth graders forget basic math that they've learned their whole life. These are also considered like terms. If they all don't have a variable, you can combine that. It's basically 5 plus 3 is 8, minus 4 would give us 4. Now, unlike terms, this slide's important. This side's important. We know that if it has different variables, you cannot combine it. You cannot combine an x with a y. This one is a common mistake. They have the same coefficient. They look alike because they both have 5. However, they are not like terms because the variable, again, the variables are different. So you cannot combine this to make, say, a 10xy. That's not how it works. Even though they have the same coefficient, still unlike terms. That would be the final answer. Last but not least, this one, again, a 3 and a 3. But because this one has an x and that one does not, that would be the final answer. You cannot combine those to make a 6x. That would be your final answer. Okay, this would be a good slide to pause. Write this down in your notebook. We have 1, 2, 3, 4, 5, 6 boxes by 3 boxes. Write expression, yes or no, and the justification, why or why not. Pause this. On the next slide, you're going to fill in the blanks. Okay, here's what you're writing down. You're going to make them equivalent to hopefully 12a plus 3x. In this box, write yes or no. And over here, explaining why or why not is this or are these expressions equal to that top expression. Now would be a good time to pause it and practice these on your own. Okay, hopefully you paused the video. Let's go over these. I see 9a plus 3a gives me 12a. And then positive 5x minus 2x does give me 3x. That one is a yes. Why or why not? They just combine to equal 12a plus 3x. 15ax, common mistake. 12 plus 3 is 15, but you can't just throw the a and the x together. They're unlike terms, so this one would be no. And you would write down your justification, can't combine unlike terms. And this third one, we have 6a plus 5a plus 1a. 6 plus 5 is 11, plus 1 is 12, so we have 12 a's. The 3x left over, so that's in our final answer. So this one would be yes. Justification, they combine to equal our expression at the top. Over here, we have 9a minus 3a. That gives us 6a. So off the get-go, we know that that one doesn't combine to equal 12a. And this one is going to be close. 7a plus 2x. No as well. Moving on. Practice these problems. I'm going to go over it here in a second. I would pause the video again and try these on your own. Okay, hopefully you pause these. Let's go through these. Looking at number 1. when I see this, I notice that they all have the same variable, meaning that my answer is going to be one final term. So 3g plus 4g is 7g, minus 1g is 6g, plus 2g gives us 8g. The next one, 3y minus 2y gives me 1y. Now remember, we don't ever write 1y, we're just going to write 1. It's implied that there's an imaginary 1 there. Then I have 2x plus 4x gives me 6x. Or if you want to rewrite this, usually you would see this one written as 6x plus y. The third one, I see 1, 2 different variables, so my answer again is going to have 2 different terms in the final answer. Let's look at our d variables first. We have 3d, positive 2d, positive 8d. 3d plus 2d is 5d, plus 8d gives me 13d. Almost done. Put my boxes around these. We have positive 4e, negative 2e. 4 minus 2 is 2, so that's going to give me 2e. Hopefully you got a good grasp on combining like terms.